Hello. So we are back. Finally Friday. And we have a job from a customer. This customer, I believe he sent me like 6 laptops. Anyway, this one has liquid damage. This is that kind of customer or I don't know, computer shop or but someone tried to fix it. I mean, every job someone tried to fix them. So this is a i5 10 gen. It's a nice Acer laptop, yeah. And the problem with this one, liquid damage. Can we fix a liquid damage? Liquid damage is tricky. I mean, you can end up with hours working on a liquid damage laptop, and on the end, it's not working. In the end, you have still a dead laptop, but you spend hours. Very, very tricky. Okay, so the laptop inside. Oh, look. The BIOS battery. The main battery is unplugged from some reason. That's fine. We can see the sticker is red, yeah? Check here the sticker. The charger is small pin. Let's find the plug. So we need something like that, right? No. This one? Yeah, this one. Power supply to 19 volts. Switch to 19, about 2 amps. Yeah, good. Plug in the charger, is taking no current at all. Do we have voltage on the input? That's a good question. Assuming the charging port is good and we have 19. The main power rail is present. We have here a bunch of power supplies. I suppose on this capacitor, and we have nothing. So what do you think? Yeah, same story. No, the main power rail is missing. So what I'm thinking is to take the board to inspect. I mean, clearly this board has been cleaned. I can see based on the color of the board. Let's take the board out and inspect. Okay, so the board is out. I mean, it's not looking bad. Look, we have a IT chip, a EC startup chip. Let's have a look under the microscope. So how the board is looking. Here was no liquid damage on this side of the board. So that means the liquid came from the back, which is good. Means the keyboard can be good. Look here. Here you have the start the input circuit. You can see this is the plus from the charging port, and you have two inductors. You have first MOSFET, you have the second MOSFET, and then you have the current sensor, and then in this big power rail is the main power rail. On the other side of the board, yeah, we can see liquid damage on the components. Yeah, check on that chip pins. You can see that's the BQ startup chip, power management chip. Sorry. Here we have the BIOS chip. Here we have the CPU power supplies driver, and clearly we can see liquid damage there. You can still spot the liquid damage. So what do you think about this? Here on the screen connector you can see some liquid damage. What do you think about this board? Here are missing components. Don't tell me. Really? No, huh? It's no missing components. Are no missing components. I mean, those dots. No, probably not. But check here. Check here. You can see liquid damage there. I mean, that's what I'm trying to tell you. If you start trying to resoldering each component, cleaning, so these can you can work hours, and at the end, yeah, the laptop can still be dead. You know what I mean? So you have to decide from the beginning if it's worth the risk or not. Or at least we can try some basic stuff to see if the board has like any sign to being alive. So how we are starting? We are starting with the charger. Let's plug the charger and let's see what's going on with the main power rail. Like how I said, the input circuit is here. So on the first MOSFET we have 19. On the output of the second MOSFET we have nothing. On the middle we have nothing. Now the next logical step, diagnosing the input circuit, is checking the BQ chip, yeah? Told you here is some liquid damage. So what we are checking on the BQ chip? First, we are checking if the chip has power. And probably the power is coming on this big resistor and has 19 volts, you can see, 19. Okay, so what I'm thinking is try to remove the chip. And let's have a look a little bit under this chip. Yeah, before we are start checking things, yeah. Just quickly, yeah. Let's pre-flow quickly this chip. I'm gonna use rosin, yeah. Rosin is good, especially on the liquid damage jobs. Let's first evaporate the alcohol from the rosin, just to be sure the rosin is sitting on the board and it's not sliding away. Good, perfect. Let me grab a tweezer. That resistor doesn't look good, but we're gonna have a look. Okay, so the chip is out and the tracks are looking okay. Pin number 1 here, good. The pins on the back of the chip are looking good. That's great, that's fantastic. Okay, so we can solder the chip back because here everything is fine. Good. Just a little bit of flux again. Look how it's boiling, it's nice, it's like ASMR. It's giving you that satisfaction, you know. Okay, so the chip is soldered, nearly there. Yeah. So this chip is soldered fine. Good, good. Now this resistor, you know what? I mean, it's kind of strange. It's like, what's that black stuff? I believe here was sugar, something sugar based. You can see that this black stuff. You see, that resistor is not good. Now, what's the value of this resistor? Tell me quickly. What is the value of this resistor? You don't know. Huh? That's what you are trying to tell me? Okay, what I'm hoping, those resistors are the one from the current sensor. This is what I'm hoping. And in this case, should be few ohms each. But let's see. So this one has... lol, is something else. No. Okay, that's bad. That's proper bad because we don't know what resistor was here. No. You see, liquid damage job, and we just started. And we have to figure out the resistor. Find the resistor and replace the resistor. This is like half an hour, only on one resistor, yeah? And you have a dozen of resistors rusted on this board. That's what I'm trying to explain you on the liquid damage job. Okay, let's try to figure out the value of that resistor. So I'm on the 200 kilo ohms range on the multimeter, and I can't see anything. Nothing. I mean, this is more than 200 kilo ohms. Yeah, it is working. Multimeter is fine. Nothing. You think it's higher than 200 kilo ohms? Like freaking nothing. Okay, if it's too big, doesn't it? Yeah, if it's over 200 kilo ohms. I'm just joking. Let's see what he's doing first, yeah? Let's see what he's doing that resistor. So we have volts range on the multimeter. And let's see what the resistor is doing. So that resistor is connected here, 19 volts. And probably this is creating the voltage detector, yeah? So here, if I remember, should be like 2.5 volts. AC detect, I believe, is the pin. Not sure. And this is a divider. So if it's a divider, you are, you know the word F, yeah? Because you need a precise resistor. Yeah, just because it's a divider, yeah? It's not like a pull-up resistor. Pull-up resistor, you can use any resistor. Nearly any. But when you have a divider and your resistor is dead, you have to use a precise resistor. Okay, let's try to find the BQ datasheet. So what pin is that one? That one is the pin number 3456. Pin number 6, yeah? Okay, let's find the BQ datasheet quickly. You see, this is electronics. This is electronics. BQ. I'm assuming it's a 24780 BQ, right? I didn't pay attention. Yeah, probably. Has to be. So, what is the schematic? Pin number 6. AC detect. What did I told you? What did I told you? Usually the resistors, they have current. I mean, in the case of liquid damage, that resistor have 19 volts. So it will get rusty quickly. Yeah. And it's this resistor. So here, yeah, sorry, it is bigger, yeah. So we checked on 200 kilo ohms range, and actually the resistor is 866 kilo ohms, and the other resistor is 133 kilo ohms. So basically, we need like 800 kilo ohms resistor. Where can I find a SMD resistor 800 kilo ohms? Yeah, trying to fix things on a Friday. Okay, let's try to find another board. And maybe we are lucky to find exactly the same resistor. If we can find exactly the same BQ chip. What do you think about that? This is a board. I don't know what board it is. I do have a BQ chip here. We have a BQ chip. Lol, I found it, yeah? I found it. 1 second. Microscope. So we have a BQ chip here. It's BQ25713, but I don't care, yeah? I don't care what BQ chip it is. If it's looking like a duck, it's making sound like a duck, must be a duck. So what do we need? We need a black resistor. Look, I found it, you see? Those are black resistors, you see? I'm joking. We are looking for the same configuration like on our board. And pay attention here, pin number 6, 1, 2, 3, 4, 5, 6. And you have two resistors, check here, this one and this one. So what do we need? We need this one, which is connected, you see has a capacitor here. Does mean the resistor is on the power rail, yeah? So most likely is the resistor what we need, this one. So this is our duck. Any more air? I mean, hopefully this is our duck. I took the duck out. Okay, let's try to solder the duck here. Oh lol, this is a big one. You know what, maybe it's a good idea to check with the multimeter the value. Because this duck looks fat. Okay, let's check together. So this duck has 200 kilo ohms. Should work even with 200. Should work, right? Yeah, should do the job. Should work. 200, 800. Yeah, it's about that. It's about there, you know. It's same duck, yeah? 200, 800, about there. Same duck. Just a fatter one, you know, a bigger one. You know what I hate the most? When actually the people, they are taking the manufacturer as a god. Okay, the manufacturer is god, and if there is a 800 kiloohms, I have to use exactly 800 kiloohms. It's nothing pissing me off than this. You know, just leave your imagination to run. You know, just use your own things. Yeah, just modify how do you like. You know. And if it's going wrong, it's something to learn. That's the thing. Yeah, it's something to learn. Okay, so this is fine, and this is fine. Yeah, we are fine. Now let me plug the charger. Where's the charger? I mean, okay, you are carrying repairs. I can understand that, and you are making money. But if you're carrying a repair and you don't really learn anything, then it's a waste because the money are coming, the money are going, and you have nothing left. You know what I mean? Okay, so plug in the charger. We plug the charger. Check on the screen. It's taking 30 milliamps. You can believe that? Wow. Let's check the voltage there on our duct. Here. So on our duct we have 4 volts, and I'm happy with 4 volts. Let's check the main power L. Remember? Main power L we checked first time on this capacitor. And the main power L is 19.2. Check on the screen. Yeah, so we successfully restore the main power L. Okay, the next step is the 3.3, but I believe it's present because it's taking 20 milliamps, a little bit too high. 20 milliamps. Check on the BioChip, we have 3.2 volts. You can see on the BioChip and on pin number 8, this is pin number 8. Pin number 8 on any BioChip is plus. Pin number 4 is ground. Yeah. So we have 3.2, that means the 3.3 volts power rail is present. And I believe we can try, where is the power button on this one? We can try to power up this board. What do you think? Where is the power button? It's on the keyboard. Oh. It's on the keyboard. Okay, let's try to check the keyboard for the power button. Track, yeah, pin. So that's the keyboard connector. I know. I soldered this chip here with the hot air and I didn't melt the connector, yeah? Smart, right? You know how many times I melt connectors? Wow. So there we have 3.3. Here we have another 3.3. 3.3, I mean everywhere is 3.3. 3.3. 3.3. 3.3. 3.3. Okay, every pin has 3.3. Which sucks. You know what I mean? Hey, here is 0. Zero? That's interesting. 0. Lol. So are not on all 3.3. So here you have 3360, 60, 360, 360, 360, 360, 360, about there, 360, ground. 3645. Wow. So there is nothing like lower. Okay, don't worry about that. Let's put the board onto the laptop and try to press the power button. So the power button is on the keyboard. We don't need the BIOS battery. We don't need it. We need the power button to see what the board is doing. Okay, so the keyboard is connected. Pressing the power button is going to 0. I mean, the current is not going up, it's going down. That's crazy. That's crazy. So actually, when you press the power button, the current is going down. Plugging the charger, we have 20 milliamps. When we are pressing the power button, the current is going to 0. That's crazy. Hmm? Hmm? Why is going to 0? Because the 3.3 must be still present there. No, I have no current. Oh, I got it. I got it. So now pressing the power button again and nothing happening. No. So actually when you plug the charger, the board is trying to come on by itself. So now the board is on. But it's taking only 20 milliamps because nothing is starting. I got it. Yeah. That's the reason why you have the power on the BIOS chip. Then when I press the power button, the current goes to 0 and the BIOS chip doesn't have power anymore. So what do I want to do? What do I want to do is try to reflow a little bit this chip. What do you think? I mean, those pins looks quite bad there. Yeah, let's do it. Let's do it. Let's come with the heat from this side. Rosin flux. Good. Looks decent. Now it's a luck thing. Yeah, you start soldering random things and you hope the board it will start working. Eventually you can pray in mind, you know. You can tell your praise there. Maybe it will work. Good, so this ship is fine, yeah? This ship looks strange, the small one. I can see some liquid damage. I can see some liquid damage here. Yeah, we have nothing to do. Then start reflowing things on the board. I don't want to reflow the biochip, just want to be sure the flux is there. That one is fine. This one looks decent. Yeah, this one looks okay. Let's clean it a little bit here. Let me grab some alcohol. My bottle is empty. I mean, everyone is using something like that, right? It's good. It's good. Lol is gone. I have to buy another one. Gone. Perfect. Working. Now let's clean it a little bit. No, on the other side is fine. There's nothing on the other side. Let's check. Because based on the current, I'm still not happy with those things here. Based on the current, is like the biochip is not rated by the chipset. You know what I mean? Can we have water damage under the CPU? We can, yeah. We can have. Yeah, it looks clean enough. Okay, let's see if it's any improvement. Let's plug the charger. Any improvement? $50 milliamps. It is an improvement. Yeah, we just go like a step forward. So we just reflow a few things, yeah, we clean it, and the current goes up to 50 milliamps, which means nothing. I mean, we are exactly on the same point, but with just a little bit more current. Yeah, that sucks, you know. Let's take the heatsink out. Let's check the coils here. Let's check the resistance of the coils. Nothing, 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 nothing. What is this? What is this? Well, this is ground, right? Oh yeah, it is. 5 ohms. 1.4 ohms. Okay, this doesn't look good. 1.4 ohms. This one 1.4 ohms. 14 ohms. 33 ohms. And this nothing. This nothing. And this nothing. 1.4 ohms. Oh, even in a gaming laptop, you know, the CPU still has like 4 ohms. 1.4 ohms. You ready? You ready? Let's go with some current on that 1.4 ohms power rail. Let's lower the voltage to like 0.7. Ground. It was here, right? It's taking like 1 amp. Let me grab the thermal camera. Let me grab the thermal camera. Yeah, that would be nice. I should be checking from the beginning, you know. Okay. It is an improvement. I believe this board it will charge. If I connect the battery, it will charge, but because the BQ chip and IO chip is up, it should charge. Let's see, 1 amp. And with 1 amp, the CPU exactly on the middle, check there. Has like a bump. You can't see. You can't see. Exactly on the middle. Has like a dot, but you don't see like a dot. You'll see like a spot, but I see like a dot. Yeah, and that's the main V-core power line. And here I see in somewhere 13 ohms, right? Five ohms, 1.3 ohms, 1.4 ohms, 15 ohms. That's strange. But it's decent. It's taking only 200 milliamps. Okay, that's decent. Yeah, nothing wrong here. But 1.3 ohms for the CPU, it's way too low. Yeah, it's way too low, way too low. This is a dead CPU. And it's hitting exactly on the middle. It's a spot. It's a dot. You see like a spot, but I see like a dot. So you can't have a CPU with 1.4 ohms. You know what I mean? No. Let me see 1 second. Wait, 1 second. Okay, this is another board from the same customer, but it's not the same clearly. But just to understand the V-core. So here the V-core has like 100 and something ohms. Wow, this is quite high. So what is this? Those are so weird. I mean, this one has like 192 ohms, the V-core. So this one and this one are together, are 2. Well, on any case, this is not shorted, yeah? Clearly. Let's grab another one. No, this one probably it is shorted. This one probably it is shorted, and I remember, I know why. It is. It's 1.4 ohms. Yeah, I know for sure this is shorted. Yeah, so that's the story with the CPUs. Yeah. It's 1.4 ohms, and that's not right. And you'll say, yes, sorry, but this CPU probably should take like 15 watts, which, yeah, is fine. Yeah, but it will take that power where it has the clock. Yeah. On the same way, like on a normal CPU, like usually you have how much? 5 ohms? Now, 5 ohms with 1 volt is 5 watts. Yeah. So you have a 30 watt CPU, and if you calculate like 1 volt with 5 ohms, and yeah, it's only 5 watts. And where are the rest of the watts? They're coming from the clock. The CPU start clocking, the current is going down, it's skyrocketing, you know what I mean? It's taking like 30 amps, like with 1 volt. And yeah. Sadly, it's nothing what I can do with this board. It's nothing what I can do. I really try to fix it, but this is a dead CPU. Wait, what did you just said? You said there's liquid damage under the CPU? Huh? Someone said that. Who said that? Okay, let's give to this board one more chance. Yeah, just one, but it's shorted. You know what I mean? It's shorted. Okay, let's go with Rosin under the CPU. You know what's the story with Rosin? Rosin, when it's getting dry, it will isolate behind each pin. You know what I mean? So let's try, because we have Rosin under the CPU. I will come with the heat from the back. It's a decent heat. It's like 440. We are not reflowing the CPU, yeah? Don't get me wrong. We are not reflowing the CPU. We're just trying to clean it in case it's liquid damage under the CPU. That's how you do it, yeah? You can see it's boiling nicely. Yeah, that should be enough. Because the idea is not to reflow the CPU. Let's cool the CPU. I check the resistance. .3 ohms. Yeah, that's the resistance. Yeah, 0.8. Lol. So basically, before of the, I always check before the coil. Yeah, I always check here. Here, yeah, we have 0.098. Yeah, that's because the CPU is hot. Oh, this is gone. So here we have 0.09, and here we have same 0.09. Okay, let's plug the charger. Let's see. Plug in the charger. Oh, sorry. Let me raise the voltage to 19. Plug in the charger. 15 milliamps. You can see nothing. Nothing. Nothing, nothing. So what you'll do, you'll choose a different approach to this repair. On. 1.1 ohm. Yeah, the CPU is getting cold and the resistance is going up to probably like 1.3 ohms, what we checked. But one more time, it's not normal. Yeah, when I came here with like 0.7 volts to see a single spot this size, yeah, this size, maybe this size here, a single spot on the center of the CPU. That's not normal. Yeah, and you can try on a normal CPU, and has to come warm the whole capsule. Or no, this is okay. No, it's not the whole. It's not the whole, but a big part is the V core, and then you have a small part which is the boosting. That's from what I see with the thermal camera when I test different CPUs. So that's how it looks, but not a spot. Yeah. So this is a dead CPU. Good. Good. I'll stop now. I'll upload the video because you know just to the way how we diagnose the board, yeah, how we solve the problem with the BQ chip, yeah, we even a different resistor, we solve the problem. Now, having in mind this method, yeah, when you have chips like maybe it's not a CPU, maybe you have a different chip, boiling rosin under it will do a great job on a liquid damage job, and I fix a lot of boards with just rosin, just surely flowy rosin. Okay, I'm really sorry I could not fix this one. We cannot fix them all. So I'll say thank you for watching. Like and subscribe if you like the video like always, and see you on the next one, yeah? Bye.